So now in this video we have an LM358. It's an op amp. We have it wired though as an Astable Multivibrator. So the output is alternating between high and low, and it's Astable, which means it never stops. I hit the power supply, that's why it did goofy stuff. The power supply voltage cuts out. But in any case, as long as you don't screw something up, it's just going to keep flashing these LEDs back and forth. Ultimately, the output is going high and low, back and forth. And let's zoom in and look at why. So first off, when the output is high, that means it connects to 5 volts as good as it can because I'm using 5 volts, and the red LED lights up. I probably, I made this diagram a long time ago, probably used a relatively high value resistor for 5 volts, because we can't ask for a lot of current out of the output. We're limited with how much current it can provide, and so I'm probably asking for very little. And then when the output is low, the blue LED lights up. You can see that path right there. And you know, it's not a perfect connection, but there you can see it looks like we're bouncing between about 2 and 3 milliamps of current for this entire circuit. And so we will come back. So again, it's going high and low. Let's look at why. When it comes to the output of an op amp, it is influenced by the voltage at the non-inverting input and the inverting input. The output wants to be more like the non-inverting input right here. And if they are equal, then it will hold a steady voltage, which is undetermined. But it's almost never going to be equal in this case, and we'll look at why. So first off, and I bumped the power supply again, that's why it kind of flickered. Let's just get out of the way so my hand doesn't keep bumping it. So first off, a lot of my circuits, we've been setting a reference voltage with a couple 10K resistors right there to get half of the supply voltage, 2.5 volts. But now we added another resistor right here. So let's go to the most extreme. If we set 5 volts with these two, and then the output, if we could get a full 5 volts, then we would have twice the voltage, or twice the current, I should say, coming from the two 5 volts, if that was 5 volts. And then we got this one going to the negative supply. So this would be twice the resistance basically, because we got 5 coming that way and 5 coming that way through 10K resistors, whereas we only have 1 coming going to the ground right there. And so that's going to raise the voltage up to probably, I'm going to guess, 2/3 of the supply voltage. Now when the output is low, it's connected to ground as good as it can do. Let's say it does it perfectly. We have the opposite. Now we got that resistor and that resistor that are opposite of the negative supply when it comes to the non-inverting input right there. So it's going to pull the voltage down because we only got 1 going to the positive supply right there. And so it's probably going to lower it down to 1/3 supply voltage. So we see that happening as the output flips from high to low. We can already see that it's flipping high to low from this demonstration. So now that is not really doing anything other than responding to the output going high or low. Here we have the capacitor. So this is the inverting input. And so if this voltage is higher than the capacitor voltage, then the output's going to be high. But that means the capacitor voltage is low. It's basically discharged. And so you can see we got a 100K resistor. The value of these two components will determine the charge and discharge timing. So in any case, we already said this one, it's a discharge capacitor for the most part. So it's lower than the voltage here. And so the output goes high and it starts charging the capacitor. So at some point, you know, if we could get to 5 volts at the output, this is going to get to 5 volts sooner or later. But we have our signal voltage when the output's high, you know, like 2/3 of the supply voltage. So once it gets to about 2/3 of the supply voltage, you know, approximately, we're just going like best case scenario. It actually won't line up perfectly. I haven't measured it, but I just know. So in any case, we get up to 2/3 supply voltage. It's charging. This is being pulled up from the positive supply, you know, at the same time. This gets to a higher voltage. Remember, this is the inverting input. If we have a higher voltage here, the output goes low. Higher voltage here means that there's a lower voltage here. The output wants to be more like what we got here. And so the output is going to go low. Pulling this voltage down. This voltage is higher. Again, when it's higher, the output's going to be low. So it's going to discharge through the output right there. It's going to be a charge capacitor. And it's going to discharge down to ground best that it can. Its voltage is going to go down. So we got the lower than half voltage here. When this gets down to that point, then this will finally become lower. And when it's lower than this one, the minus is lower than the plus, then the output goes high. We don't have to use a 10K, probably 100K would work exactly the same. You know, as long as we have equal value resistors, and they don't even have to be equal values, we could tweak this, but that's just what I have right here. And again, the load here is also asking for current. The amount of current that the LM358 can provide is limited. It'd be actually better to send this to like MOSFET transistors. They don't need any current and they can switch LEDs. But that's topics for other videos that I have covered. And yeah, I wrote notes basically mentioning what I explained in greater detail. And I don't think I showed the power supply. I was looking at it earlier. I got it set to 5 volts right there. We have our flashing LEDs. In fact, since we have the 470 ohm resistor right there, unless you know, the extra current demands messes things up, I should be able to get up to 9 volts. So yeah, we're asking for quite a bit of current from this, but yeah, looks like it's working perfectly fine. I think the timing is the same, but again, the output isn't a perfect like current source. Can't provide unlimited current. So the more we demand of it, it may throw off the timing, because you need to provide current to the load plus current to the timing. But there, it worked both ways. We have flashing LEDs if that's our goal. We can tell they're flashing. They're not flashing so fast that you know, they just kind of both look like they're lit all the time. So it's working just fine. Let's go back to 5 volts. Now I'll turn the power off and we can take a closer look. So the capacitor there, I have a jumper coming down. So that's to the inverting input. So second pin down. We have an op amp over here. Ideally, you would take this op amp, and best solution I know of is to put ground to the plus input, and then minus input, tie it together with the output. That will hold the output to ground. You don't have a load or anything, but it'll just lock it into place. And so that's probably what you should do, but I always check the data sheet, what you should do with unused pins. And of course, you don't want the output going to a supply voltage itself, because that would be a short circuit. But the input, you usually want to tie them to something. Putting the output to an input is not making a connection, electrical connection. So it's just sensing the output at that point. So yeah, we got the blue LED, and hopefully you can see that it's coming to the positive supply there. So we know it's the long lead, the anode up there, short lead, the cathode, coming to the output. I do this all the time, so we'll pluck these first. They're common connections. Then we got the output to the red LED. Short lead, the cathode, going to ground. Long lead, the anode. When the output's high, it conducts. You got to put LEDs in the right way, or they won't light up. And so you know that that longer lead was to positive, shorter was to negative. Unless you cut this one shorter, then you would have the opposite. So best not to cut them unless you absolutely have to. There's also a shaved edge on these, I believe, where the cathode is, the shorter one. Yep, you can kind of see that. The lighting changes versus when it's round and when it's shaved, when the shorter end is going. We're not going to worry about that too much, but there is a little shaved edge. So yeah, now we got the output, and so this is the 10K. It's going to the non-inverting. the plus, I angled it like that to make room for a resistor going that direction. But yeah, 10K coming to the other two 10Ks. So again, these two want to make it like half of the supply voltage, but when the output's high, it pulls that voltage up. And again, they want to make it like half, but when the output is low, right there, it pulls it down a bit. So the output is either going to raise it or lower it. We never actually get that half voltage the way that we have this wired up. And then again, this was going to the capacitor, and that's the inverting input. Again, they're just looking at the voltage, the input's right there. So 100,000 ohm resistor, the output's high, the capacitor charges. Oh, I was thinking I moved the capacitor. The output's high, the capacitor charges, and when the output is low, the capacitor discharges through the output right there. So it's moving both of these voltages at the same time, but this one's always trying to get to the voltage of that one. And when it finally reaches it, the output changes, and it has to go in the other direction to try to reach it. Its value, how long it takes to charge. Larger capacitors take more current for their voltage to change. It's a direct relationship. The current coming in will be the voltage change, but the higher the capacitance, the more current to get to a certain voltage. Hopefully that makes sense. And then, so yeah, you limit that with the resistor right here. And, you know, I don't know what would finally be the limit when it comes to using larger resistors. Capacitors also have leakage and stuff, but 100K isn't too bad. It can charge and discharge this capacitor pretty quickly. 10 microfarad capacitor right there. It is electrolytic, which means you have to put it in the right way. So again, we have the shorter lead going to the negative supply because I have not cut them. The longer lead I use you know, to jump gaps and stuff right there. It works out pretty well because I haven't trimmed it. If you have trimmed them or you see them like on a board, they were soldered or whatever, there is a gray band. This is not a well lit gray band. I can see it in person better though. But in any case, there's a gray band for the negative side. And to end this, I rewired this so this would flash. I actually just thought I had to add the LEDs and I'd be done. And then I turned the power on. But what I saw was this, which was really odd. And I realized it was just rapidly going back and forth. Pretty sure that is what it is doing. And that's because we have the output coming to the inverting input. The output keeps going high and low. That raises and lowers the voltage of our non-inverting input right there, but it also instantly raises and lowers the inverting input voltage in a greater at a greater voltage. So basically, as soon as it notices this goes high, then it's going to tell this to go low, and this goes high. So it's probably oscillating as fast as this integrated circuit can do. If I yank the 100K resistor right there, so it doesn't come to the inverting input, it's going to lock into place. Since there's no feedback, whatever state it was in, right when I yanked it, it's going to lock in place. So I just forgot to put the capacitor back, but I thought that'd be interesting to mention right there, because sometimes when a circuit is not doing what you expect, they both look like they're on, but they're also dim. I knew they were alternating extremely quickly, and I had to troubleshoot why. I just looked down and noticed nothing was there. I had the capacitor off to the side like I do now, but if I put it back, again, if it has a stored charge, it may change the output, but it would stay in place. So whatever it switched to, if it switched, it would stay in place, but we don't have that, so must have already been at the right charge to keep it in place here. But yeah, in any case, hope you found that interesting. Thanks for watching. Make sure you check out one of the other videos I posted to the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.